Describing motion. Each video in the series will start with the outcome slide. These are a few dot points from the subject outline. Now I won't read them every time, but what you can do is print your own subject outline and cross off each dot point as we go through it and you understand it. This way, by the end of the topic, you'll make sure that you hit every dot point and also make sure that I don't miss any. So in this video, we'll be describing motion, which is a little bit of a recap from year 11. Just for information, right at the top is the subtopic title. Next to that is the content of the slide, which can either be the outcome, the content itself, or question. And just here is a specific slide topic. Right, let's get into it. So the first thing that we're going to talk about in motion is distance. Distance is related to the position of an object at a certain point in time, and it relates to how far the object has traveled. This has units of meters. Now, distance is a scalar quantity, which means it's only described by its magnitude and it doesn't have a direction. So with the example of the ruler on the screen, the distance you might measure something might be 2 centimeters. Now, although I said centimeters there, it's a scientific convention that we use meters in all our calculations. This helps with the communication that we have between scientists. Related to distance is a term called displacement, which is how far the object has moved from its original location. And, importantly, the direction as well. So you can see on the diagram on the screen that both distance and displacement are identified. The object's path is shown by this blue line, as you can see. The distance is actually the path that it takes and how far it traveled along this path, but the displacement is only related to its original position and is denoted by this green dash. Displacement has the units of meters and is a vector quantity. So being a vector quantity, it means that the magnitude and direction is important in describing displacement. The next way we're going to describe motion is with the word speed. Speed is the rate of change of the distance the object travels related to time. This has units of meters per second, as distance is in meters and time is measured in seconds. This is a scalar quantity, which is just magnitude only, and it's given by the formula on the screen. The term velocity is very similar to speed, however this is the displacement with respect to time. It has the same units of speed, but it's a vector quantity, meaning that not only does it have the magnitude, the direction is also important. What you can see with the diagram on the screen, the cars going into the screen, you can see their brake lights being red, and the cars coming out of the screen, you can see the headlights, which are white. Both cars on this highway might be doing 100 k's an hour, which will be the speed of the car as shown on their speedo. But they both have different velocities, as one's going away from us and one's coming towards us. So that direction is important. Now you can see the formula on the screen is very similar to the one for speed. However, this one has a line above the S, which denotes the displacement. So that line suggests that it's a vector quantity, meaning that direction is important. The final way we're going to describe motion in this course is with the term acceleration, which is a change in velocity with respect to time. So this has units of meters per second squared, and because it relates to velocity, which direction is important, acceleration is also a vector quantity. So you can think about acceleration as what's the velocity at one point in time and how has it changed to the next point in time. So the velocity is changing. Now importantly, because velocity comprises of two components, which is the magnitude and direction, if the velocity magnitude is changing, the object is accelerating. But if the direction of the object is also changing, it can also be accelerating. Alright, in this part I want to put acceleration and velocity together and get you to picture yourself inside one of these cars and think about what you'll be doing to control the car. So for this, let's assume that right is positive. Let's start with the Ferrari, which is the red one at the top. Now, if the acceleration is positive and the velocity is positive, how will the car be moving? So I start with the velocity. If the velocity is positive, the car is moving to the right, meaning it's in reverse. And if the acceleration is positive, the velocity is increasing to the right, which means that you're inside the car in reverse and getting faster and faster. With the yellow Porsche, the velocity is negative, which means that you're traveling forwards in the car, which is to the left. If the acceleration is negative for the Porsche, it means it's increasing its velocity to the left. So the Porsche is actually traveling forwards and getting faster and faster to the left. With the third one, the grey Audi, the velocity is negative, meaning the Audi is traveling to the left, but the acceleration is positive. So it's changing its velocity to the right. So this Audi is in reverse going to the left. However, it's slowing down, and eventually if you wait long enough, it will start traveling to the right. And the final one, the green Mini, velocity is positive, meaning it's to the right. So the Mini is traveling forward, but the acceleration is negative, meaning it's decelerating, so the Mini has its brakes on. Okay, this is the final part of the video. Each video will have a question to have a look at. I'd like you to spend the time doing this just one question every time. Some of them are short, some of them are long. And for this one, I'd like you to identify the vector quantities.